My name is Alex Borde and I run the product organization here at MetalSoft. And in this video, I want to elaborate a bit on a more recent feature that we've added in our latest version of the MetalSoft Fabric Manager, which implements the support for Cisco NDFC. Now, this support is different than other drivers that we have, such as the Cisco ACI, in the sense that we don't only talk to the Cisco NDFC solution, right? For Cisco ACI, for example, we talk to the AP controller, and the AP controller provisions everything on the switches, right? EPGs and so forth. In contrast, the Cisco NDFC implementation uses something that Cisco calls network as code. Right? So we don't directly write to Cisco NDFC, but in turn we talk to a Git pipeline that will then talk to Cisco NDFC, right? And this is an important change because it accommodates change control practices that organizations already have in place, right? So, so we have a Git system, which could be GitLab or something similar. In a normal operation, you'd have an operator do a push, typically followed by a PR, right? So they push in a branch and then create a PR to merge that branch into the production branch, right? And then this is usually accompanied by an approval process. Approval, right? And the PR along with the delta or the diff gets sent to somebody that has this authority to do approve a pull request, will approve it and then merge it, and then Cisco will invoke a pipeline, and that action or pipeline will then talk to Cisco NDFC, typically via Ansible, and Cisco NDFC will apply the changes on the switches. The files that are in Git are usually in YAML format. Right. Now, if the organization wants to use MetalSoft, and I'm going to represent MetalSoft here. So MetalSoft will execute all write operations to Git in a manner that's almost identical to what a human operator would do. It will amend the respective YAML files as required. So for example, if you want to implement a logical network between two servers, that translates into VLANs on certain switches. And so we update the files and the entries in the files with the allocated VLAN that MetalSoft allocated. That is pushed to Git in a feature branch, and a PR can be created. Now we have two ways of operating. We can either create PRs or we can do a direct push, but generally speaking, from what we've seen, customers prefer to do, for us to do a PR. But because MetalSoft is not just a automation solution that just blindly throws something in the air, we're an orchestration solution, right? So what that means is that we also need read access so that we know the state of all the switches and what's been provisioned, how it's been provisioned, and so forth, right? And so we have read access to the NDFC controller. And so we write via Git and we read directly. And this has implications also on our AI. So if there's there's an incident, there's a health issue that's detected by MetalSoft, then the AI is invoked, and the AI has the capability to receive information about the current state and potentially do a little bit of troubleshooting and append the results of the troubleshooting to the ServiceNow ticket or email that we send out. Right? So this is how it operates, and the end result is that customers can have both the benefits of a software-defined data center and easy segmentation and client-driven operation of the data center rather than humans having to do everything. But at the same time, they can have the change control processes in place that they already have, and they can reuse the existing investment in Cisco NDFC. Thank you for watching.